Good morning, children. We are beginning this morning's class from where we left out when we had the last class. I had given you this schedule showing the relationship between PP, MP, and AP. Okay? It is the same schedule which I had given you the last time when we had a class. And I had asked you to draw your PP curve, your MP and AP curve from the schedule. Now you will write down the relationship between PP and MP. We will do two together. The relationship between PP and MP. So the heading is relationship between PP and MP. First point, when PP increases at an increasing rate, MP also increases. MP also increases. That is up to third unit. Up to third unit. Second point. When PP increases at a decreasing rate, when PP increases at a decreasing rate, MP declines but remains positive. That is, in brackets you can write from 4, 5 and 6. 4, 5 and 6. When PP increases at a decreasing rate, 80, 90, 90, MP declines but remains positive. That is from units 4 to 6. Third point. When PP reaches its maximum, when PP reaches its maximum, MP is 0. Fourth point. When PP starts declining, when PP starts declining, MP becomes negative. Where is that? In the 7th and 8th unit. You can put it in brackets, 7th and 8th unit. Okay. Now we will take the relationship between AP and MP. Next heading, relationship between AP and MP. First point. When MP is greater than AP, AP increases. AP increases. is more than AP is increasing. That is up to the 3 units, first, second, and third. These three. In brackets, you can write up to third unit. Second point, when AP is equal to, when MP is equal to AP, when MP is equal to AP is maximum. If you see, AP is maximum. That is in the fourth unit. AP's value is 20. When MP is equal to AP's value is the maximum. Third, when MP is less than AP decreases. AP decreases, that is from the 5th to the 8th unit. Fourth point, MP increases or decreases more rapidly than AP. More rapidly than AP. And the fifth point, MP can be 0, but AP always remains positive. MP can be 0 or negative, add on one more word. MP can be 0 or negative, but AP always remains positive. That is why, children, if you look at the diagram, you will find the NP comes to 0 and also goes into negative. But what do you see about AP? When you draw the AP curve, it will always remain positive. It will not touch 0 and it will not go into negative. This is the relationship between the three. And draw this diagram using your scale, pencil. This is the TP and it is drawn with the schedule given here. On the x-axis we have the units of labor 1 to 8. On the y-axis we have T, which is maximum 1 to 90. 1 to 90, then you plot it. 110 you get a TP curve. You plot on the x-axis again units of labor, on y-axis we will plot MP and AP. MP begins from 0 and goes up maximum to 30 here. Here also maximum goes up to 20. So you can have here, draw both of them and then we will give the relationship. Is that okay, children? So this diagram has to be done in your copy. And all diagrams will be drawn with your pencil. Next we have you all finished this? If you all have, please give me a thumbs up. Okay, 1 is given, 2 is given, 3 is given. Any more? Good. So we go on to the next. The next is returns to a factor. returns to a factor. I'm running on this question. Returns to a factor or law of variable proportions. Returns to a factor or law of variable proportions. Okay, write down. When only one variable or factor is increased, keeping other factors constant, the resultant change in output within brackets PP and NP, brackets closed, is called returns to a factor. Now write down law of variable proportions in terms of law of variable proportions in terms of PP or PPP. I am keeping the same schedule what I had given you earlier. I am keeping the same schedule. The law of variable proportion in terms of PP or PPP. The law of variable proportions states that if more and more units of a variable factor within the brackets labor are employed with the given quantity of fixed factors, initially the total product increases at increasing rate then it increases at decreasing rate reaches its maximum and finally declines. Next is the law of variable proportions in terms of MP or MPP. The law of variable proportions in terms of MP or MPP. The law of variable proportions states that if more and more units of variable factors in bracket labor are employed with the given quantity of fixed factors initially the marginal product increases then it decreases to 0, then it decreases to 0 but remains positive, and finally, while declining, it becomes negative. So, according to this, there will be 3 stages. This is the first stage. This is the second stage. And this is the third stage. In this, we can remove the AP because we don't have anything to do with the law of AP. So, if you have it, well and good. If you don't have it, it's not required. Now, what do you see in the first stage, student? The law of variable proportions according to the TP. Look on the board. The first column is fixed factors. What is the fixed factor over here? The fixed factor here is land. We have 1 acre of land, let's suppose. Okay, when we employ a variable factor, example taking a variable factor here is labor. When we take it first, 1 labor, that labor is able to give us a total product of 10 units. Okay? When he increases it to 2, the output increases, PP becomes 30. When he increases 1 more, 3, it suddenly jumps from 30 to 60. It is increasing at an increasing rate, very fast. Then what happens? When the 4th labor is employed, we will see that PP will increase from 60 to 80, and in the fifth unit 80 to 90, sixth unit no increase at all, 90. So PP is increasing, but not like how it was here, directly from 10 to 30, 30 to 60. No, it is increasing, but at a decreasing rate. And at the sixth unit, there is no extra contribution. Then, if for some reason the seventh laborer is put in, do you think his contribution will increase? No. The total product instead of increasing starts decreasing. In other words, we don't need this laborer over there. Because this was an indication. From 5 to 6 there is no increase. We should have stopped here only. 5 people are enough to give us maximum. Still we said 6. 6 maintains that 90, not more than that. But here, when we employ the 7th unit of labor, the TP starts decreasing. 7 and 8. Instead of getting more output, we are getting less and less. In other words, there is an overcrowding there. We don't need that. This the law states according to TP, law of variable proportions. The law of variable proportion in terms of MP. What do you see? When 1, 2 and 3 units of labor are introduced in the 1 acre of land, initially MP will increase, but not as much as EP. EP was increasing at an increasing rate, but here MP is only simply increasing. Okay? Then, when we add on the 4th, 5th and 6th unit, what happens to MP? From 30 it starts declining, 20, 10 and comes down to 0. MP will start declining but will remain positive up to 0. That is when the 6th unit of labor is introduced on the 1 acre of land over here. Then what do we see? When the 7th and the 8th laborer is put in, instead of getting any positive, we will get into negative, minus 10 and minus 20. And you know how to calculate MP, no? PP n minus PP n minus 1. So 10, 30 minus 10 is 20, 60 minus 30 is 30, 80 minus 60 is 20, 90 minus 80 is 10, 90 minus 90 is 0. What was the formula I had given you? MP is equal to PP n minus PP n minus 1. That was the formula. Yes? That's how we get PPN is suppose 30, PPN minus 1, 30 minus 10 is 20. PPN is 60, minus n minus 1, 60 minus 30 is 30. So according to that, we can find our NP. So in the first stage, we find it is a stage of increasing return. Stage of increasing return. The second stage is called the stage of decreasing return. The stage of decreasing return. And the third stage will be stage of negative returns. Stage of negative returns. So the law of variable proportions can be studied through TP or TPP and MP or MPP. Now, when we draw the diagram, what would you take on the X-axis, unit of labor. 1, 2, 3, 4, 5, 6, 7, 8. This is labor. And what would you take on the y-axis? You can take TP and MP. Okay. When you draw your diagram, what did you see? TP will increase. TP will increase at an increasing rate. Then it starts increasing at a decreasing rate, and then it starts declining. This point, from the point of origin to the point where it increases at an increasing rate, this point is called point of inflection. INFLEXION, point of inflection. So write down what is point of inflection. It is the point, write down, it is the point from where the slope of TP changes. It is the point from where the slope of TP changes. Up to this point, TP has been increasing at an increasing rate, and from this point onwards, TP increases at, and from this point onwards, TP increases at a decreasing rate. That is ending of first stage and beginning of the second stage. So point 16 is the point of inflection. First, second, third, very rapidly it increases. This point is at an increasing rate, then it increases at a decreasing rate, it reaches its maximum, and then TP starts declining. So this point from where TP increases, it is the point from where the slope of TP changes. From this point onwards, TP has been increasing at increasing rate. After that point, it starts increasing at a